Okay, Lena's here. Let's see.
I just messaged. Stephen is in a meeting with Dave, which is why he's late.
Oh.
I think we all know how that goes.
Oh my God, you got virtually schwartzed.
You got virtually schwartzed. He said, "I'm just finishing up with Dave." I sent him a message waiting on you. He said, "Just finishing up with Dave," which means he'll probably be ready in about a half.
Well, again, we are recording, so we'll give a couple minutes, and we're there. He is. There he is. Hi, Steven.
Hi. Sorry, it took me a moment. I just finished up another meeting. So.
Yep. Yes, we heard. Yeah. All right. Well, we still got a minute or two here, so we'll give you guys all a chance to get your thoughts. Screen sharing should be on, so you should be able to share any of your slides or materials. So let's just double check that one last time. Yep, sharing all participants. Good. All right, there's Erica. All right, looks like everyone is here, and I'm assuming a few people will join in a few minutes. So welcome to today's capstone presentations. We're going to start off with the team control CTRL. And the way this works for new people, we have the students present their capstone for the first 45 minutes. I will hold up a sign, if I can find it here, or give you some sort of indication if we get down to students running out of time. I asked during the presentation that people hold off their questions unless it's an emergency thing by the committee. And then at the end, I will open the floor to questions by the committee first, the faculty second, and then the general population last. Okay, so team, are you ready?
Yeah, we are ready.
All right, I am turning the floor over to the team. Go ahead, guys.
Okay, hello everyone. Welcome to the final presentation of Capstone Project D.I.V. And thank you for coming today. We are Team Control. In the summer of 2019, we have done this prototype to demonstrate the core game mechanic and the playstyle we want in the final project. In this prototype, the player could deflect bullets with normal attack and move around in map with dash attack. The large and strange bumping character on the top left side is the initial design we do for the energy system. The core game mechanic and the playstyle are there. We believed in our design concept, and we are ready to transfer this concept into an actual project in a year. When we look back at this point, there are still many similarities in the core game mechanic and the playstyle. We want to create such a game which can combine moving, jumping, and attack together, so that the player needs to move, jump, and attack at the same time, which means they will encounter combat during their platform movement, and on the other hand, kill enemies could also speed up their level exploration. So, what is D.I.V? D.I.V is a fast-paced action platformer with the cyberpunk world setting. It is also a single-player 2D side-scroller. We designed the main character with strong mobility. With our level design, there are a lot of diverse solutions or paths you can take for a single level in D.I.V. We hope players could perform amazing skill shots frequently and also feel the satisfaction and accomplishment from what they have done in-game. The core mechanic player will use most frequently is dash attack. In D.I.V, the player could use the mouse or controller left stick to indicate the direction they want to dash toward. And each dash will consume 1 dash energy to cast. There are 2 different types of dash energy in-game. The main character will take 1 normal energy and 1 overload energy at most. And each energy type has a different recovery mechanic. Normal energy can get recovered each time the player is grounded. Overload energy can get recovered by killing enemies or reaching an energy recharge point. And also during the dash, the character will become invulnerable for 12 frames to dash any attack or lasers. In level 2.1, a new mechanic get unlocked, which is power dash attack. It has a longer dash range, and the control remains the same with the dash attack. Power dash has its own cooldown and do not need any dash energy to cast. This skill is quite powerful and useful in level 2.1 since the player needs to do a lot of long distance airborne movement at that level. There is also a normal attack that does not require any energy to cast. The attack direction is also bound with the mouse or control left stick. And in addition, normal attack could deflect the projectile as long as the player has the right timing. Favor is a powerful ultimate we designed which could be activated by players for short durations. During that time, normal dash energy recovery will also trigger overload dash energy recovery. It will also apply a time freeze to slow down enemies' movement and projectile.
And after talking about our gameplay mechanics, we will give a brief introduction about the other mechanics that related to the level, and including the enemies and some other in-level elements. And all enemies are designed to be at 1 health, which allows the player to simply kill them with a single attack. And killing enemies can recover the overload energy. And we have enemies like melee robots that features melee attack and dash attack. And we also have gunner drones that fly in the air and shoot bullets to the player. And they are also designed to connect those platforms. By killing a drone, the player could do one more dash attack to reach a higher place, and which could not be done with just a single one dash. And we also have laser bolts that stick to the wall and shoot a laser beam. And the player needs to dash through it to avoid being hurt. And also, laser bolt is like a guidance to tell them and they can actually make use of the wall jump. Because by killing a laser bolt, the player would usually get onto the wall so that they could perform a wall jump naturally. And we also featured a boss fight in this game. And it challenges how well the player use their skills. And most of the time, the boss will hold up a shield in front of him, and he will block the player's attack. And in order to land a hit on the boss, the player must strike when the boss is left open before or after executing an attack. And the way to beat the boss is dodging and attacking at the right timing. And each backstab can hurt the boss. However, the player can still stun the boss by attacking them from the front. And for the other in-level elements, we have energy charge points that can charge an energy to the player, no matter it's normal or overload. And unlike enemies, energy charge point is permanent. It will stay there and recharge through time, which means the player can make use of the same charge point repeatedly. And we also use this to create some challenges that require the player to do multiple times of dash attack. And for the laser hazard, it's actually the laser beam itself. Unlike those laser bolts, they cannot be removed. And we decided to use the laser to let the player get familiar with dash attack, and then provide some new challenges. And bouncing platform can bounce the player to a certain direction. And it can charge a normal energy, which means the player can make use of the bouncing platforms to change the position in many different ways. And based on all those mechanics, we designed the level structure of D.I.V. And we have 4 levels and 1 boss fight. And in Chapter 1, the player would face 3 levels with some basic enemies and in-level elements. At the end of the Chapter 1, the player would encounter this boss fight. And for the Chapter 2, we implemented 1 level. And in this level, the player will unlock the ability of Power Dash, and there will be laser bolts as a new kind of enemy. And to be more detailed, in level 1.1, we will teach the player how to play this game, including controls, core gameplay mechanics, and some basic enemies and level elements. And our method of tutorial are mainly cutscenes, hints of button, and some level design language, for example. And there is a platform on the top that requires the player to jump and dash, and which can help them know they can combine jump and dash together. Or there will a horizontal laser that requires the player to dash upwards twice to get through. And the goal of the level 2 is to let the player get familiar with dash attack. And in this level, the player will play around with charge points and lasers that could help them get used to the dash attack. Charge points can help them be aware of they could dash for multiple times, and lasers could help them get familiar with the distance and timing of the dash attack. And for the level 3 is to let the player make use of the dash attack. And the critical path of this level is pretty straightforward and contains many enemies. And also we introduced the bouncing platform in this level. And through the play test, we found that most players like this level. And since they are easy to stay focused when dashing and killing and interacting with those bouncing platforms. And there is a boss fight at the end of the chapter 1. It forwards a challenge, and the player needs to fully utilize dash attack to win this battle. And after that, the player will move to the chapter 2 and get the power dash ability. And this level contains higher platforms and longer ways so that the player could make use of this new ability. And we expected that the player is somehow skilled at this time. So we designed harder challenge based on the lasers, which requires them to carefully deal with. And we also introduced laser bolts. By killing laser bolts, the player could somehow reduce the difficulty. And after the overview of the level structure, we will talk about the design goals for each level. And as we said in the game concept, we want the player to perform amazing skill shots frequently and gain the sense of achievement by doing this. So we decided to use enemies as the stimulus. To beat down plenty of enemies, the player needs to use their skill frequently. And with the positive feedback provided by the overload energy, we expected the player to feel powerful so that they could be willing to use the dash attack more often. And more than that, through play test, we found the player typically like to go forward without hesitation. And so we decided to make the level more intuitive. And whenever the player gets to a new place, there will be an obvious way to leave the area or some lower platform that can be easy to reach. And we want to get rid of making the player sit there and think what to do. And the other design goal is multiple solutions. And we found that dash attack provides a really amazing mobility to the player with various possibilities. So we will not restrict the ways to solve a platform puzzle. And there are various paths for the player to choose. And we still have some intended solutions that fit for different player groups. For example, a faster but harder way for the speedrun players, or an easier way for the players who just want to beat the game. And the faster way usually requires the player to manage their dash energy, figuring out when and how to use the dash attack. And about my individual research, I mainly looked into the level design of other action platformers to get some inspirations. And if you have played Katana Zero, you might find our enemies have a similar attack patterns, but we approached them in a slightly different way. In D.I.V, the design goals of each enemy is more like disturbing and guiding the player rather than obstructing them. And we clearly know that we want the player to enjoy the fast-paced dash and killing, and enemies can provide a sense of achievement and encourage the player to do more dash and killing. They are more like a platformer element rather than some obstruct, and they can be taken advantage of by the player. And as a result, we designed them less aggressive and less deadly, put many of them into the level to make players feel powerful, and use them to create different solutions. And in terms of enemy distribution, we found that Katana Zero puts enemies into different rooms. The player would not face too many enemies at the same time. And also, the player can know the enemy distribution in advance so that they can choose their own way to beat the level. And reflecting in our game, we divided the level into many parts and used enemies to connect them to keep the player concentrated. Also, we carefully deal with the camera to guarantee the player to have a proper view of the scenario. Now, when they are progressing the level, they can always see what's next, so that make their choice quickly. And along with the multiple solutions, the player can easily find their own way out. And also, we found that there is a group of people who like to explore the game and collect things up. In Hollow Knight, they create hidden rooms that contain secrets. And like these games, we also have secrets. If the player could overcome a challenge, they will be rewarded with a secret. And the difference is that after the player collects a secret, they do not need to go back. Instead, they can approach the following level from a new start point. For example, as we can see in this picture, the player originally entered the level from the bottom right. But if they collect the secret on the top, they can approach the level from the top, which becomes a new solution of the level. And more than that, we have some hidden paths that are challenging but faster. The path on the right is the regular one. However, the hidden path on the left is clearly faster but challenging.
For the art production, I like to start with the art development process. For each level in our game, as you can see here, our level designer will offer a settled level layout draft to our concept artist after iterating the level many times. That means the whole level structure won't change too much in the future, though there may be subtle changes. Then the concept artist will work out a concept art of the level that defines each area's general content and style. Then other artists will make the art assets accordingly. Last, our team members will place the art assets with the concept art as references. During the process, the steps may be overlapping with each other, so that none of us need to wait for others to finish their work, which considerably enhanced our efficiency. Then I want to talk about the art style. The main art style for our game is pixel style. The actual resolution varies from 32 by 32 to 11:8 by 12:8. This is because the assets in the different layers have different resolutions due to its importance. The sprites in the foreground would be in low resolution, and the characters are in high resolution. On the left, there are some examples of our pixel art style assets. For the background and the UI, the art is solid color style and focusing on colors like pink, purple, red, and dark blue. We think such styles and colors are consistent with our level art and would help convey the feeling of a cyberpunk world. For the portrait, we adopted illustration style because the characters in the game are in pixel style, and we want to show the details of their traits, face, and clothing. We have done many iterations during the development process, and those can be classified into three categories. First, we refined our art workflow. At the early stage of the development, where our art pipeline isn't settled yet, the work of the concept artist is actually done by the level designer and the level artist. The workload became unbalanced, and all the work is jammed at the beginning phase or the ending phase. So we refined our art workflow to the one I just introduced. The second is that we did many corrections on the existing art assets regarding the perspective. At the end of the last semester, we found bunches of assets has an inconsistent perspective of view, and some of them are from left to right and some are from right to left. So we discussed the issue and determined to use the horizontal perspective. Last, we also made some art composition changes and assets polishments. The general goal is to better reflect the world settings and make our scene eye-catching. In the iteration process, we also referenced many games with similar settings or assets, like Katana Zero, Transistor, Kamen Rider Rush, and those games helped us forming our own art and style. Now I want to talk about the art composition and the expression elements in our game. And those elements helped us deliver a world with dynamics and aesthetic feeling that can attract players in the first place. And the animation in our game is divided into three parts: character in-level mechanics and the environment animation. The character animation include protagonist and enemy animations. And the in-level animation include bounce platform animation, unlock door animation, that is mainly intended to guide the player and give player feedback. Environment animation like moving spotlight are intended to create a sense of realism and player presence. Particles are important to show intensity and strength. Thus, we utilized particles in many aspects, especially on the character skill. We think particles are powerful to convey the strength of laser and impacts. Navigation. Some art assets are specified to guide the player. For example, the arrow icon indicates the right direction for the player to go, and the big giant hollow figures shows that the player is going in the right way. Lighting is also important in our game, since one of the key elements of cyberpunk world is the massive usage of lighting. So almost every area in our levels have a specific lighting configuration. We also used parallax scrolling to create the illusion of depth. And one of the most important effects is the dash effect, since our game focuses on high mobility and encourages players to use dash frequently. Whether the effects of dashing is satisfying becomes a big issue. So we put lots of efforts enhancing the dash effect by adding layers, light, and animation. To have a good graphics quality, we also introduced the Unity post-processing stack. For the audio part, I'd like to start with the audio production process. Before actually making and editing sounds, we made an asset sheet in the planning stage, marking all the possible events and the required sounds. This allows us to work in a more efficient way. And according to each entry in the asset sheet, the first thing needs to do is to check the sound quality and use Reaper to process those sounds for the first time. The purpose is to remove unnecessary noise and select the clip we need to use. After we had the cleaned and edited clips, it was time to bring them into FMod and do a second process. In this stage, the effects are added to the sounds at runtime. So most of the time we add effects like reverb and EQ, since it is easier to see the results in real time. When the sound design is done, we need to integrate FMod in the Unity project and do some programming to make it work in our intended situation. And normally, we have to continuously adjust the effect until it meets our expectations. For the background music, it is mainly from the Demendo music site, and the music style is 80s synths and dark themes, because we think the styles have some kind of rebellious spirit that could fit our game settings. And the sound effects are either created by ourselves or found in the free audio libraries like Freesound and Zapsplat. And the ultimate goal is to improve the overall gameplay experience, and the sub-goals include providing extra information for players and creating the feel of an authentic world. And for my individual research, the individual research topic is 2D lighting. The main ways of bringing 2D lighting into a 2D game before March 2019 are within the three aspects. The first is using the third-party tools like 2D Pro, which can give the developers the flexibility to develop and design their lighting in a proficient manner. But the learning cost would be higher than the Unity's built-in functions, and the cost of money is not a negligible factor. And the second is continuing using the 3D lighting system available, but the problems are the performance and the feasibility. And the last is creating a 2D lighting system independently. However, for a small team like us, it is not realistic to make a new 2D lighting system since we are focusing on design. But luckily, we get to know the newly released Unity 2D lighting system at the beginning stage of our project. And the advantages of 2D lighting are in the following aspects. The first is that the system has lots of lighting preset and adjustable settings. And the second is that the performance cost compared to the 3D lighting is much lower. And so developers can freely deploy lights without caring too much about performance. And the third is that it provides advanced lighting features like local mapping, masking, and blending. So the system is able to meet complex lighting requirements. So with the new lighting system, we can design the lights in a more flexible way, and we add lights without too many restrictions.
Yeah, moving on to the technical part of the product. So we chose Unity as our engine. We chose Unity because of two main reasons. First, this product is not an engine product in which we are not going to make our own engine. Therefore, we have to use game engines that are available to the general crowd, especially free engines. Among those kind of engines, Unity is the most familiar engine for us all. For our team members, we have nearly no experience on other commercial engines such as the Unreal Engine or the CryEngine. In this case, Unity becomes the first choice. Second, we are making a two-dimensional game, and Unity has a better community support for two-dimensional games. There are only 175 search results for 2D on UE4 Marketplace, while there are over 8,000 results on the Unity Asset Store. In this case, we may get a better support from other people if we use Unity. So for technical designs of the game, we have roughly two big parts of the technical aspect in our game: the core gameplay and optimization. First, any technical choices for the core gameplay should support the core idea of the game in terms of the design and production. By this, I mean we want our code to be robust but not overkill. According to the design, I divided the gameplay part into 5 subtopics: level loading, player character, enemy AI, data, and the graphic user interface. Second, any optimizations should be independent with the core gameplay so that they will not interfere with the game experience we want to create, but only improve the product from technical perspectives. For the level loading, we decided to use Unity prefab instead of scene loading. The first consideration is that we do not want any loading screen between different levels so that we can create a smooth experience for players. By using prefabs, we can load multiple levels at the same time, so it is guaranteed that there will be no loading between those levels. However, in practice, due to the size of each level, there is actually no significant waiting time for scene loading. However, we did stick to the original idea since we found it to make us easier to manage the game flow on the fly. So finite state machines. We use finite state machines a lot of in our game. We use them to control the player character, to control the enemy AI, and to control the entire game flow. In this sense, we want to create a system that can be applied to all those fields. As we all know, a finite state machine can be separate to the machine itself and its states. The machine is used to keep track of which state the machine is running, and the functionality of the machine will be determined by the state at which it runs. As the diagram shows, we have 2 different classes for the machine and states. In each machine, we have an array of states which the machine will run with. We have an integer value to keep track of the starting state of the machine and another integer value to keep track of the current state at which the machine is running. The transition between different states is realized through the update function in a way that the return value of the function indicates the next state index into which the machine will go. Beyond the initial design, we introduced the C# generics and Unity script object to improve the system. C# generics is very good for distinguishing these different types of machines, since different types of machines contain different states which have different functionality, and there can make different machines function differently. The script object let us to easily manage the parameters of those machines by taking advantage of Unity editor. We use this version of the finite state machine for the entire fall semester. However, as we use this version, we found a problem needed to be improved inside the system. We found that using integer indices to keep tracks of different states was very ambiguous, since we cannot directly tell the functionality of different states by seeing those integers. Therefore, we changed those integer indices into string names so that we can have a better sense of what those states are doing when we are programming the machines. For the data management, we use two kinds of methods to manage our data. The first method is using serialized variables. This method is very useful to manage data on individual game objects because different objects can have different values of those serialized fields. The second method is using a data table system. The method is good for data that is consumed by multiple parts of the game at the same time. In this case, changing those data should have effects on anywhere else inside the game the data is used. For the data table system, the system is made up with three classes: data table manager, data table, and data table entry. We borrow the idea that a table can be viewed as a collection of rows to implement the system. In the system, the data table entry class will serve the role of each row in tables, and the column will be represented by the member variable of the data table entry class. At runtime, all tables will be automatically loaded at the start of the game. As we can see through the diagram, data can later be safely retrieved by calling the getData function in the manager class. Currently, the system is used by many parts of the game, such as the dialogue system and the enemy AI system. At the right of the on the screen, this is an example table used to record the basic attributes of different types of enemies. The GUI system. GUI is always important for our game. Usually, many interfaces are used to deliver different kinds of information. Therefore, it is very important to get those interfaces under proper management. We use a customized system to manage our GUI. The system relies on the Unity prefab to instantiate different interfaces on the fly. The system is made up with three classes: GUI manager, GUI window, and GUI widget. Both GUI window and GUI widget are abstract classes. The GUI window class is used to manage the whole GUI, and the script should be attached to the root object of whole GUI prefab. The GUI widget class is used to directly manage the components of Unity graphic user interface. The goal to have the GUI widget class is to increase the code reusability to boost the production efficiency of writing GUI scripts. All open GUI interfaces can be retrieved by calling the getGUI function inside the manager class, or they can be directly managed by calling certain functions of the GUI manager class. So moving on to the optimization. In our project, we also made a lot of optimizations through code. The first optimization is the object pool. Object pool is a common design pattern in computer software. In our project, object pool is used to minimize the instantiation and destruction of certain game objects, such as visual effects and bullets. Those pooled objects usually have a very short lifetime but have a high frequency of usage. Those objects are often destroyed immediately after their instantiation, and this process can happen very frequently, which may easily cause small glitches in games. At the start of the game, the object pool will initialize a set of objects which are inactive but ready to use at any time. Whenever an object is ordered, the object pool will activate one of the inactive objects and use the object without any instantiation. After usage, the object will be returned to the pool and inactivated so that it can be used again. So as a part of my individual research, the second optimization we made is about the control of frame rates. The idea that the frame rate can have major impacts to game mechanics was first brought to me when I made a mistake last year in the prototyping class. Later, I looked into a game I usually played, Monster Hunter World, and found similar problems caused by different frame rates. As we can see in the GIF, the same bowgun can have different fire rate under different frame rates. Similar to the previous GIF, the type of ammo can have different hit number under different frame rates. The problem was caused by the imperfect smooth time in all games. For example, you are writing a script in the Unity for a gun that fires a bullet every 2 seconds. Theoretically, you can fire 4 bullets in 8 seconds. However, in the real game with this given code section, you can never get 4 bullets out in 8 seconds because you can never fire a bullet every exact 2 seconds. The problem can be generalized in many cases, especially those when a certain action is repeated in a certain time interval. In our game, we have those drone enemies that fire bullets to the player every 2 seconds. I manually adjusted the fire time to fit the exact 2-second time interval so that the enemy can fire at the exact rate we want.
The game and physics optimization is my individual research topic. During the development, we realized the limitation and inconvenience of Unity original physics system in a 2D platformer. The rigid body could not solve everything for us, which encouraged us to develop and customize the physics for our game. In this image, when a character is turning around, the character will have a small delay and also some sliding happen occasionally. The problem in here is the subtle deceleration movement, which will keep pushing a character to move in an original direction a bit. After the speed is zero, it will decelerate in a new direction. The way to fix this is to cut off the deceleration, kill current speed, and set the max speed in a new direction. This solution actually is a simplified version of game physics, but one problem by using this solution is it will kill all the external momentum when there is an input. For example, if the character is on bouncing platform, after the character get bounced, the momentum or speed should not be changed or reset by upcoming input for a while. Otherwise, it could not be a natural bounce jump. So a lot of conditional code need to write in here to implement the simplified movement physics. After removing that, the character should move faster and which is easier to control at the same time. The next physics optimization we made is a dash. To optimize dash feelings, we applied additional drag and velocity dividers to simulate the speed reduction after dash. In comparison, the latest version on right has a more smoothly ending after the dash finished. Speaking of game development process, the development phases have been divided into several milestones. Each milestone of that will contain considerable amount of feature updates and bug fix. On the day of each milestone, we will send the latest build to our artist teams for an internal test. In addition, there are two major public playtests holding in the past 1 year to gather information from publics. After collecting the feedback from our testers, we will hold a meeting to discuss the following plan and make a detailed to-do list for the next milestone, and also a short postmortem to address the problems we found regarding communication, art assets, implementation, and design. We have on-site stand-up on Tuesday and Thursday. Besides this normally weekly stand-up, we also set a Saturday meeting with our artist team to update progress. Also, a weekly task sheet is used to track the team progression and task assignment. We will update the task sheet after every Saturday's meeting to match the plan with current development progress. For postmortem, the first things when right is the team productivity. All the team members, include our external artists, communicate actively to solve potential issues and are capable to take challenges. Thanks to that, we could deliver 4 levels plus 1 boss fight in a year. The second thing works right is the pre-production stage. We spent 3 months in the summer of 2019 to finish all the narrative and the concept design, enemy AI, art standard, and level production flow. The pre-production ensured us could pay more attention to develop D.I.V in the rest of the year. It's a key to our productivity. What went wrong? In the pre-production stage, we spend a lot of time and effort to design the world setting and narrative part of D.I.V. At the start, we believed D.I.V was a narrative-driven game. However, as the time goes by, we found the art resource we could utilize is much less than we thought. To demonstrate our story and explain the world setting, more art is required. If we could have the right estimation for our resource, we could spend this time on developing any other content of the game instead of designing our narrative. That's the end of our presentation. Thank you very much for coming to D.I.V's our final presentation. For more information, please check our website, and you can also download the demo to try it out by yourself. And at this point, we want to say thanks again to all the people who have contributed to our project and all the faculty members. Yeah, we are finished and we are ready to take any questions. Thank you.
All right, thank you guys. I'm going to start off this time with Stephen. Stephen.
Okay, yeah, sure. I wanted to say, well, one, in general, it's been an absolute pleasure working with you all this year, and the things I really enjoyed were, one, your passion for your game. That I was thinking to myself while watching this presentation. I often saw you all when we were in the labs playing your own game and having a great joy in that, and I think that was kind of says a lot. I also love that you had a great process. That you were very open to listening to criticism and feedback, and that you took every thought seriously. And I think that was it was really great because it became evident in seeing the week to week or the milestone to milestone iterations how much things progressed. It was pretty fantastic. I think for the part that I was involved with mostly was the sound, and I think that was also a really great enhancement and a big part of the experience of playing the game. I thought that it was really enjoyable. The difference between the early iterations and later iterations, the feeling of the sound as dashing through and wiping through all these enemies, hearing all of the interactions, really added a great deal. And I thought the work done on that, to spend time to iterate, multiple times to get it right, really impacted the final result. And that in realizing actually at the very end here during the presentation that this wasn't even the focal point of individual research for Yan was kind of amazing that this much extra work that was put into this was done on top of the individual research there. I think I don't really have any questions. I mean, except, I would say if there had any question, it would be the narrative. It was, I'm glad it was brought up at the end there. I remember at the beginning of the year, there was a whole lot of discussion of narrative, especially at the initial pitch, and that some of the early prototypes had experimented with that. I do think it was very good that was the priority of that was de-escalated. I wanted to ask, because I thought about this too, and looking at the breakup of the levels, there is still remnants of narrative in the initial tutorial, and then you don't see it again. And I think that's probably not unusual for having just one main slice and then a 2.1 there. Could you just go over again the what are the future plans for the narrative, and how many levels are planned, and how that all ties in?
Okay, so for the entire game flow, in the original design, we have 4 or 5 chapters, and now we have one chapter. One chapter is 3 levels plus 1 boss fight, and so in total, if the final form of this game should be 15 levels and 5 boss fight, and we plan to add 1 new mechanic after each chapter. So it's like power dash in chapter 2. And if there will be chapter 3, maybe some grappling hook or other stuff, or some like additional platform, something like that. Yeah.
So I don't remember, like at the very beginning of the tutorial, there is some kind of interaction with I forgot his name. Is it Jack or?
Yeah, that's right.
Yeah. So is there a plan to have this kind of mini cutscene on each of the chapters?
Oh, yeah. So for the narrative, we still plan to have some dialogue before the level and at the end of the level. We don't want to break the entire gameplay experience. We don't want to player to have dialogue while they are in the level. So the mini dialogue will still happen since we done a lot for the narrative. We still want that to present to our players, but in order to because of our resource, we cannot just present too much. We just can show a little bit like a stack of them. So we will still have this mini dialogue happened before each level and at the end of each level to give like general sense how this world is working and what's the relationship between the character. That's yeah, that's it.
Okay. My only thought about that is moving forward, because there wasn't as much time to cover the development of narrative. My only thought would be to try to minimize and be as efficient with conveying the narrative in future cutscenes. To use to say as much as you can with as little as possible to as you say not break up the experience too much.
Okay.
But beyond that, thanks so much. I really enjoyed the presentation and the whole experience of this throughout the year, and the final product is quite a joy. So thank you.
Thank you.
All right, Ian or Sten, you need to go. Do either of you need to run right away, or
I can go after Ian. That's not a problem.
okay? All right,
I'm
Ian.
good either way.
Okay, go ahead, Ian.
Okay. So yeah, I mean, like Steven said, I mean, it's a great project. So I'm going to focus, less on that, because I've been giving you feedback the entire year about that. So I want to just focus on a few questions. First is kind of a generic question, but something that I like to ask in every presentation, which is just we have some first year grad students that are observing here, and from the things that you went through this year, they're going to do capstone next year. What advice would you give incoming teams for next fall?
Oh, so there are part of them we have already talked about in the postmortem. I think the one of the most important thing is the pre-production stage of this project. We spend 3 months in pre-production stage. There does not involve any code development at all. We all do this on paper, like concept design, like art overflow and art workflow, and the level production standard. These kind of things has helped a lot in our following procedures and save us a lot of time so that we can focus on code and negotiating with our artist team. And this part, I think, is very critical for the capstone project. I think every group should start early and design their own game early and have the prototype early, and to make rules for your game development early. And after you get this standard, you can start to development your game really quick. The second part I think really important is team composition. Um, in the start of our game, in the start of the capstone, we did not think the capstone is just a place we could design our dreaming game, but we want the project to have some values after we graduate, so we can take away or we can just use this to go into some like industry, game industry, like a portfolio piece. And so we want this project to show the power of each team member on each fields. For example, in our team, there is one team member is focused on the programming really heavily, and 3 of us are doing design. So we trying to develop this kind of skill set and to show this power in our game. That's also one concern you need to have when you just set up a capstone project. And I think these two factors are really important in capstone project.
Yep. Okay. I like that. I think I'll pass that on to the first years on their Discord.
Okay.
Here, because I think that's good advice. So thank you. I've got two more questions. The next one is regarding future work, and I mentioned this to you all on the Discord last night, but I didn't have time to put that in. But if you were to take this project forward, like what do you see that's kind of like missing in the current the final build here that you would that you would prioritize to say, like, these are the things that we would do first if we were to if we were given additional time to take this project forward even more.
Okay, so for the future plan, and in fact, we do not have any future plan at this point, since since all the team members just split up into just start their next page of the life and go into work or somewhere. And if we do have the chance, we want to take this project forward. And I think the part where we're working on most is to solve all the resource to get more R resource. So once we have more R resource, we can do narrative as we want, and also develop a more diverse mechanic in this game. Since we want to at this point, I think finish the entire game flow is one of the big topic for the game. And since we already built all the base system and the level working flow, so all we left is just content creation and art and content creation and debug and polish. Yeah, I think that's it.
All right. And the last question I had was, I thought it was really interesting that and this is more just a conceptual thing, and again probably more benefit for the first years in terms of how you chose your committee, because I noticed that, like, in terms of research, I know one of you did level design, and none of us are level designers, and then the other three kind of did more tech focused things with, like, how to do these kinds of conceptual things in in Unity, and how to kind of make the engine do things that it didn't normally do. So a very technical focus, and yet Stephen's consulting mostly on sound, Stan on art, me on design. None of which were tech. That said, the final project came out really well, but it's kind of interesting that you chose. It's like you almost chose committee members specifically to fill in gaps rather than to advise you on your core research. And I'm wondering kind of what the thinking was with that, and kind of why you chose that strategy, or if there's something I missed there.
Okay, first things, and the part that Stan helped us in this project is level design, and he really helped a lot. And the way we're choosing faculty members is because we want to strengthen like to show our strengths in this project. Since we in the first, we determined all the career like career goals for all team members. Like there are three of us want to be a game designer, one want to be a game developer. The game designer have different focus. So some of the one of them want to be level designer, another one want to more fall into the audio, and another side, and I'm that general guy who can do everything. So we want this project, as we said before, we want this project to show the strengths of all team members, and so they get a lot of help from this project when they go into the industry. And we want the faculty can develop our skill in this field to make that even more powerful, so that when we go into industry, that will be more useful as this case. In all, rather than just let the faculty feel our individual research. I think the individual research is a part of the work you will done automatically with the game if you have that passion, and you will do a lot of integration and you will do a lot of research for the game. I think that's not a big issue. It's really need to have the dedicated faculty member to working with you with that stuff. Yeah.
Okay. All right. Thank you. That's all my questions.
Okay. Thank you.
All right. I'll add the comment to Ian's too. They had me also for the technical side. So that yeah, is true.
That's fair.
Okay. So Sten?
Yeah, what do I say? I mean, it's it's a complete package. I mean, I don't really have a lot of questions. Steve stole my narrative question. That was what I was going to ask you about, but now that's answered. So, and Ian covered a lot of great stuff as well. I thought the team composition question that Ian asked was really a good question. I just mainly want to thank you guys for the opportunity to work with you. It was an absolute joy. I mean, as other people have pointed out, you listened to feedback and you incorporated or didn't, and always had a good, solid reason for why you did each. I really appreciate, as part of this presentation and part of the Q&A, you talking about the pre-production process. I'm an old film guy and an old animation guy before my life is interactive, and I try to tell people that message, that pre-production is, you have to do it 3 times as much if you don't do it when you're supposed to do it. And it's just wonderful to hear a young game development team actually recognizing that and being able to show the quality of work that you get when you actually think about pre-production early and often. The other thing I wanted to point out, and I guess I'm not really talking to you guys, I guess I'm talking more to the first years here, because this is really, everybody should be listening to this and taking really good lessons from it. The idea of focusing on your project and what it's going to help you with in your careers, rather than falling in love with your project and making your dream game. I thought that was an excellent comment. I think that's super important, because the bottom line is you got a year to make a game, and that's not enough time to make your dream game. So the fact that you guys understood that and wanted to focus on your how it would contribute to your careers, and still did such a beautiful job, it's really a testament to you understanding the process the way it should be. So I mean, I really it was really a joy in the presentation, seeing your early versions of it and seeing how much it's developed. Your presentation itself was incredibly balanced. You had everything in there. You touched every category, even Dr. Yee's favorite one, the sound. I mean, that was just, I was sitting there, my heart literally got warm for him, because he's been missing that so much. But you guys did a great job, and I look forward to following your incredibly successful careers that I'm anticipating you having. And that's really all I have to say. I mean, I don't have any questions. I don't have any criticisms. I think you did a great job. I think you guys are very professional.
Thank you.
And you did an amazing job. So
thank
you. No, really, thank you.
All right. Other faculty? Any faculty questions?
Hey, this is Jessica, and I know the group already said that they're not looking for, they're not going to take this forward, but if you were going to take it forward, is PC really the best platform for this?
There is another part we did not mention in design, is the control design. Since in the very first phase of the design, we want this game to use mouse to just do the control for mouse pointing for attack direction stuff. So that's will be more precise and natural way to do in this game. And we actually try to tried in the playtest to just let the playtester use the controller to finish this game. But actually they can do this quite right. But this question is really good. I think at the end, this game should be adapted to any other platform like Switch or something else.
Okay, thanks.
Whoops. Any other faculty questions? Okay. Then I'm just going to open the floor for any questions from anyone in the audience.
So not a question. Just like everybody else, I think Ian and Stan and everybody covered the lessons learned and questions I would have asked you for the first years. So for me, just a congratulations. I checked in with you every now and then, and you were all always chugging along and taking feedback, and you were organized, and so it was a pleasure to watch you work.
Okay, thank you.
All right. Any other comments? So if not, I'm going to conclude with like everyone said, it was a pleasure working with you guys and watching your workflow and how you did things. Every week I saw progression. Every week I saw answers to questions that you had. I saw the level of experimentation you did with everything. And that was important because I think you really got to some of the fundamental mechanics problems and interaction problems that are very easy to overlook or to move past because of expectations of the genre and other things. So, for me, it certainly was very nice to see that process. And again, it's one of those things where, for next year, talking about your process to the first years is when they're second years is going to be really important because there were so many things that were done right by your team that were very, very important and I think led to an incredibly successful product. So thank you guys. It was great being involved in what you were doing. Okay. So
thank you.
So thank you. All right. So we're going to conclude this one. We have one more this afternoon. So thank you everyone for participating and thank you for being here. And looking forward to seeing everyone in the afternoon if you can attend. Thank you.
Thank you.
Thank you.
All right.